Linear equations. The very first thing you want to do for each problem that you're working is identify what's going on in the problem, what type of problem it is, so you know how to go about working it, solving it, simplifying it, whatever the case may be. And one of the first things you typically want to do is identify whether it's an expression you're given or an equation. An expression does not have an equal sign, so you cannot solve an expression. All you can do is simplify an expression. Anytime you're simplifying, you want to follow the order of operations, parentheses, exponents, multiplication, division, addition, or subtraction. If there is an equal sign, it's an equation, which means you can solve it. There's a lot of different types of equations, so you have to then identify what type of equation it is so you know how to go about solving it. Now, one important property of an equation is that you can basically do anything you want to one side of the equation as long as you do the same thing to both sides. And we're going to be using that property quite often, solving various equations throughout the course. The first type of equation we're going to work with is a linear equation. Has an equal sign, so it's an equation, but what makes it a linear equation is that all the variables will have an exponent of 1. And we know exponents. We know if an exponent is not shown, it's automatically 1. So given a variable x, if it does not have an exponent shown, it's automatically 1. Now, the linear equations in this section that we're going to be working with are primarily going to have only one distinct variable, or linear equations with one variable they'll be referred to. They're called linear equations because they're going to graph a line, but we're not going to get into that until next chapter. For now, we're just going to work on solving them. The steps to solving a linear equation is to begin by simplifying each side of the equation. So there's that word simplify. Follow the order of operations. Simplify the left-hand side of the equation as much as possible, and then simplify the right-hand side of the equation. Get all your variables that you're solving for on one side of the equation. Now, technically, it doesn't matter what side you get them on, but just to be consistent, I'm pretty much always going to be getting them on the left side of the equation. And then we want to solve for that variable. In other words, get it by itself or isolate it. And we're basically going to do that by using the order of operations backwards. I'm going to begin by getting rid of any addition or subtraction, and then I'll get rid of any multiplication division. At that point, you have isolated the variable, but don't stop there. Anytime you solve an equation, you always want to take a minute and check your work by substituting that value back into the original equation, and then the left-hand side should equal the right-hand side. So example 1, start with a couple pretty basic examples, but still nonetheless, going through the steps, it has an equal sign, so it's an equation. Our only variable x has an exponent of 1, so it's a linear equation with one variable. Step number 1, each side of the equation is already simplified, so nothing to do in step number 1. Step number 2, we only have one x, so it's already on one side, so nothing to do in step number 2. Step number 3, get it by itself. Begin by getting rid of any addition or subtraction. So on the side with the variable, the left-hand side is being subtracted by 4, so the opposite of subtracting 4 is to add 4, and once again, whatever you do the one side of the equation, you have to do the both sides. So on the left-hand side, that minus 4 plus 4 cancel out, leaving me just the x is equal to the right-hand side. 7 plus 4 is 11. So at this point, I'll solve the equation, but once again, I want to take time to check it. Plug it back into the original equation. 11 minus 4 is equal to 7, which checks out. 7 is equal to 7. Example 2, equal sign, so it's an equation. Your variable x has an exponent of 1, so linear equation. Step number 1 is already simplified each side. Step number 2, our only variable is obviously on one side as well. So step number 3, isolate it. In this case, we do not have any addition or subtraction, but we do have that multiplication. 8x is 8 times x, so the opposite of multiplying by 8 is to divide by 8. Whatever you do the one side, have to do the both sides, so they cancel out on the right, leaving us x is equal to 7. And once again, check it. 8 times 7 is equal to 56, so we know we have it correct. Example 3. Negative 5, 6x is equal to 15. Has an equal sign, so it's an equation. X has an exponent of 1. And we know how to simplify or work with fractions. So the way we get rid of multiplication of a fraction is we multiply both sides by the reciprocal. So negative 5, 6x is equal to 15. We're going to multiply both sides by the reciprocal of that fraction, which is going to be a negative 6/5. On the left-hand side, a negative times a negative, first of all, is a positive. Multiplying fractions cross cancel. The 6's become 1, the 5's become 1, which leaves us 1 over 1, or just 1x, or x. The right-hand side, If it helps, you can turn that whole number into a fraction by putting a 1 under it. Cross cancel. 15 is divisible by 5. 5 goes into 15 3 times. 5 goes into 5 once, which leaves us negative 18 over 1, which is, of course, just negative 18. Example 4. See an equal sign, it's an equation. We have m in two different terms. They both have an exponent of 1, so it's still a linear equation. And since it's only one letter, it just shows up a couple of times. It's still a linear equation with only one variable. The value of m will be the same in both terms. So still, both sides are already simplified, so still nothing to do in step number 1. But now step number 2, we need to get all the variables on one side. So as I said, I'm always going to get them on the left-hand side. So a positive 9m, I'm going to move to the left, subtract 9m from both sides. That leaves me negative 6m minus 11 is equal to 5. And step number 3, get that variable m by itself. Begin by getting rid of any addition or subtraction. Add 11 to both sides. Negative 6m is equal to 16. And finally divide both sides by negative 6. So m is equal to negative 8/3. Number 5, problems are getting a little bit larger, but still take the time to identify what's going on in the problem, and then the steps will walk you through every single one of these linear equations. Equal sign, our 1, 2, 3, 4 t's all have an exponent of 1. So just go through the steps. Step number 1, simplify each side. Left-hand side, combine like terms. 13t plus 72 is equal to the right-hand side, combine like terms. 28t minus 28. Get all your variables on one side. I'm going to subtract 28t from both sides, leaving me negative 15t plus 72 is equal to negative 28. And finally, get that t, your variable, by itself. Subtract 72 from both sides. Negative 15t is equal to negative 100. And divide both sides by negative 15. T is equal to a positive 20/3. And I'm not taking the time to check each one of these solutions, but of course, like I said, you should be, especially on the test. Sooner or later, you will make a mistake, and checking it will catch those careless mistakes. Example 6, equal sign. The ends variables all have an exponent of 1, so linear equation, simplify each side. Combine like terms there on the left-hand side. Step number 2, get all your variables on one side. I'm going to subtract 6n, moving that 6n over to the left-hand side. It cancels out on the right, but in this case, it also cancels out on the left. If all the variables we're solving for cancel out, that means we certainly can't solve for it any longer. So that means one of two things. Either there's no solution to the equation, or there are infinitely many solutions. So even though the variables cancel out, we still have an equation left up here that's telling us 14 is equal to 28, which is a false statement, so therefore no solution to that equation. If all the variables would have canceled out and the remaining equation would have been something like 14 is equal to 14, in other words a true statement, that would mean there's infinitely many solutions or all real numbers. But in this case, once again, no solution. Number 7, p is equal to a plus b plus 2c. Obviously have more than one variable in this case, but it's still a linear equation. All the variables have an exponent of 1. The fact that p is by itself on one side of the equation, it's solved for p right now, and we're asked to solve for c. So we follow all the same steps, getting c by itself, simplify each side, which we cannot do. We only have one c in the problem, so it's already on one side, but if we want to be consistent, get it on the left-hand side, we could, of course, just swap sides, write it as a plus b plus 2c is equal to p. And then get c by itself, get rid of that plus a and plus b, subtract a, subtract b from both sides, leaving us 2c is equal to p minus a minus b. And then just divide both sides by 2, so c is equal to p minus a minus b all over 2. Now the equation is solved for c. Extra practice, just a few additional problems to work. Number 1, linear equation with one variable, obviously. Step number 1, both sides are already simplified. Step number 2, once again, that b is already on one side, it's on the right, but if we want, we can switch it around so it's on the left-hand side. So now isolate it, subtract 8 from both sides. Negative 6b is equal to 10, divide both sides by negative 6. b is equal to negative 5/3. Example 2, Simplify each side. The left-hand side, combine like terms. 5x minus 9 is equal to 9 plus 5x. Get all your variables on one side. I'm going to subtract 5x from both sides. So in this case, all the variables cancel out, leaving me the equation negative 9 is equal to a positive 9, which is a false statement, so no solution. Example 3. Simplify each side. Distribute that 2 on the left-hand side. 6n minus 2 is equal to, combine like terms on the right. 6n, I'm sorry, that should be 6n plus 2 is equal to 6n plus 2. Subtract 6n from both sides. Leave me 2 is equal to 2. All the variables cancel out, and the remaining equation is true. 2 is equal to 2, so therefore there are infinitely many solutions, or all real numbers. You can substitute any real number you want into the equation for n, and the left-hand side will always equal the right-hand side. Number 4, linear equation with one variable. Step number 1 is already done. Step number 2 is already done. So step number 3, add 7 to both sides, leaving us negative x is equal to negative 12. Right now, x is still not isolated. That negative, remember, is a multiplication of negative 1, so the opposite of multiplying by negative 1 is to divide by negative 1. So finally, x is equal to a positive 12. Number 5, simplify each side. First of all, it's a linear equation still with one variable. Simplify each side. The left-hand side, distribute that 13, 39x plus 52. Distribute the negative 7 minus 14x minus 35 is equal to 5x minus 13. Combine like terms. 25x plus 17 is equal to 5x minus 13. I'm going to get all the variables on the left-hand side, so subtract 5x from both sides. Leave me 20x plus 17 is equal to negative 13. And finally, get that variable by itself, subtract 17 from both sides. 20x is equal to negative 30. Divide both sides by 20. X is equal to negative 3/2. And number 6. Still a linear equation with one variable. Simplify each side. The left-hand side, distribute that 6. 6x minus 12 is equal to, the right-hand side, distribute the 2. 4x minus 8. Subtract 4x from both sides. 2x minus 12 is equal to negative 8. Add 12 to both sides. 2x is equal to 4. And finally, divide both sides by 2. So x is equal to 2.